This is TWIS, This Week in Science, episode number 987, recorded on Wednesday, September 18th, 2024. Take out the trash, pour out the cats. I'm Dr. Kiki, and tonight on This Week in Science, we are going to fill your heads with forgetful bees, human cement, and cats in tight places. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer, disclaimer, disclaimer. To some, science is just an endless series of super interesting observations, fun facts, and unexpected realities of the world around us. For others, science is the art of turning those observations into life-saving treatments, technologies, and methods. Science is a tool for changing the world for the better. If we, for a moment, look back through time, not all the way back, just a little bit back. 100 years ago, we couldn't cure an infection. 50 years ago, we couldn't treat HIV. 20 years ago, we couldn't have created the COVID vaccine. And today, we're closing in on eliminating many cancers, Alzheimer's, and Parkinson's disease. Science is more than a method of observation. It is bigger than the process of research or the discoveries that come from it. Science is millions of people you have never met dedicating their lives to making yours better so that you can indulge in the endless series of super interesting observations, fun facts, and unexpected realities of This Week in Science coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening, what's happening, what's happening this week in science. What's happening, what's happening, what's happening this week in science.
Good science to you, Kiki and Blair.
And a good science to you too, Justin, Blair, and everyone out there. Welcome to this episode of This Week in Science. We're back again. We have a whole week full of science. I know I had a whole bunch of stories that we're not going to talk about tonight, but there's a bunch of stories that we are going to talk about.
Oh, good.
I mean, don't you want to know? I have like a whole browser full of tabs that are just left
That
out.
covers all of it. Science
It
that will
does.
be discussed and science will not be discussed. That is all science.
That is
It
all.
is
You've done it.
I've done it. Good night, everyone. Yeah. Okay, I have stories tonight. We've got the 2024 Ig Nobel Prize winners to announce.
Oh, I love
My
those.
favorite time of year. Breathing nanotubes, liquid cats, thinking algorithms, and memory signals. What did you bring, Justin?
I've got coral reef thermometers, trashy beaches, squid-based spy gadgets, and making cement from human bones.
That sounds like fun.
Future. It's the
Yeah.
future.
Recycling.
Oh, no bones about it. Blair, what is in the animal corner?
Well, I have some quick headlines regarding plants, just because they're important also. And then in the animal corner, I have decoy dolphins, and I also have forgetful bees. I forgot about the forgetful bees, and then I remembered them.
Wait, I thought the whole thing we've been learning about the bees is how well they remember. Now you're going to
Well,
tell us they're forgetful also? Oh,
Stay
gosh.
tuned, Justin.
Bees.
Obviously,
They have it all.
Decoy dolphin?
Yeah, it's like
Decoy
those
dolphin.
decoy ducks. Somebody like
Yeah, like I always
sculpted it
wanted
out
one
of
of those as a kid.
wood.
I thought
They're
those were the
not
coolest. For
that
some
far
reason, I had
off.
an insane fascination with decoy, the little plastic ducks. And like, I wanted one for Christmas once. And my mother
We're gonna
was
talk
even
about it.
like, that's too.
Now I know what to get you for Christmas someday. Okay. Or for your birthday, whatever. As we jump into the show, everyone, I want to remind you that you can subscribe to TWIS all sorts of places. Find us as a podcast, places where podcasts are found. Find us weekly, streaming live, Wednesday, 8 p.m. Pacific time-ish on Facebook, Twitch, and YouTube. You can also subscribe there, get notifications for all of our live broadcasts, and also, asynchronous time delayed watching if that's what you're into as well. If you need any information about the show, our stories that we're talking about, or anything else, head to twist.org for more information. Now it is time for science.
Although, before we get into the science,
What?
this is I just was reading the thing that podcasting turned 20 years old.
Like a few years ago.
But we were already podcasting before it was called podcasting.
Oh, that's right. I guess 2024, 25. 25 was when the iPod came out, right? Is that what it was?
2005?
We weren't even...
No, I thought 2005 was when the iPhone came.
Oh,
no,
gosh.
That was later. That was like
it was
09.
the...
But before that,
directory,
do you remember what it was called? Asynchronous listening.
Yeah, it was doing a show. Yeah.
Anyway,
okay, it was
I thought you were doing a callback
by British journalist Ben Hammersley.
24. So I guess that is 20 years. Good job, everyone. Happy anniversary, podcasting. You have come a long way.
Happy
Thank
birthday.
you, all of you who've been
But no
with us
drinking.
since before we started podcasting.
We're an American podcast.
No, yeah. Only American podcasts aren't old enough to drink. Okay. But you know who may have been drinking or not, but just drinking in the good times? Oh, yeah. The winners of this year's Ig Nobel Prizes. Every year, I like to report on the winners of this award, as it is just a fun celebration of creativity in science. The fun that researchers can have, and also the celebration of the unexpected results.
Yeah.
Or just studies got published and wow, really? Somebody published that? How fascinating that you spent time doing that. It's a celebration of the mundane, the bizarre. It's wonderful. I love the Ig Nobels.
Every year, I think, or at least some of the years, it depends on the content of the Ig Nobels. But every time, I always try to find a way to defend them in terms of I can see how this will be actually really useful.
Yes. And some of these awards are to research that had been done long, long ago. It's not necessarily research that was just from last year. Some winners are awarded for work that occurred a long time ago. So, for instance, the Peace Prize in the United States was a USA winner, B.F. Skinner. And if you've ever heard of a Skinner box in psychology, that would be B.F. Skinner. B.F. Skinner has won the Peace Prize for experiments to see the feasibility of housing live pigeons inside missiles to guide their flight paths.
No, I feel like this has been attempted.
1960, pigeons in a pelican.
Okay. Yeah, this is okay.
Like I said, it's an old study.
Yeah.
Yeah, it's not laser guided; it's pigeon guided missiles.
The problem, as I recall, and I wasn't there at the time, so I only vaguely remember hearing these stories from the older folks as I was growing up. It worked to a degree. The problem was it was mostly ended up targeting old men on park benches.
Yeah, people in zoos, children in zoos with boxes of Cracker Jacks
getting taken out.
Oh boy. The Botany Prize was awarded to researchers from Germany, Brazil, and the United States, Jacob White and Felipe Yamashita, for uncovering evidence that some plants, real plants, Bocchilla trifoliolata is the name of the plant that they studied, imitate shapes of neighboring artificial plastic plants.
That's amazing.
Bocchilla trifoliolata mimics leaves of an artificial plastic host plant.
Oh, that's brilliant.
Study. Isn't that amazing?
That is. I mean, we're going to blend in because that one doesn't seem to have a single predator.
How?
Yeah,
How do they do this? What eyeballs? What
information on that for sure?
There's no signals
this is a
stress coming from that plant. But how does it? How does it
do it? You have no eyeballs. How do you?
Yeah.
What are you doing?
Wild.
Oh Oh, the webs, the viney webs of plant life.
I mean, if that's
Anatomy.
what.
Anatomy has been won by France and Chile. Marjolaine Willems, Quentin Henoch, Sarah Tunon de Lara, Nicolas Cogain, Vincent Fleury, Romy Ragues-Igué, Juan Jose Cortez Santander, Roberto Requena, Julian Sterneman, and Roman Hossein Konsari for studying whether the hair on the heads of most people in the Northern Hemisphere swirls in the same direction as the hair on the heads of people in the Southern Hemisphere.
Oh my gosh. What'd they find?
You will have to dig into that study for the answer.
You didn't bring the answer? Oh my god.
It's the title, to give you a little hint: Genetic Determinism and Hemispheric Influence in Hair Whorl Formation. That's good. Medicine prize. Switzerland, Germany, and Belgium have taken that one home. What? You're whirling?
I thought that whole thing was. I thought that whole thing was a myth, like with the toilets. I thought that whole thing was a myth. Maybe I'm wrong, but I thought that was a myth. I thought it had to do with like tendencies of there to be different manufactured and distributed of toilets that caused the different swirl. That it wasn't actually a hemispheric gravitational anything.
So the study determined that hair whorl in different hemispheres, that counterclockwise whorls are more common in the southern hemisphere than the northern hemisphere. Could be environment, could also be genetics. They don't know.
Okay.
Yeah. I don't know either.
More common, like 90% or like 51.5%.
And the water whorl is a myth. That is the water whorl is a myth, but this is genetics. It's not anything to do with water coming out of your shower or whether you got too many
counterclockwise whorls
toilet shampoos. Yeah,
in the southern hemisphere.
But like the southern hemisphere.
Yeah.
Okay. But like much
you
more common.
It is genetically
now I'm like fascinated by this. I don't know why they got ignoble. Now I'm like extremely fascinated.
It's because they celebrate the whimsy and the fun, the creativity. Who decided to study this? These people did, and they.
No, I'm not challenging that. I'm saying like, no, I want.
Blair's
wanted to learn more.
reading the study right now.
So it's anyway. So yes. So they claim that it is genetically determined, and they plead for large-scale epidemiological assessment of hair whorls in several northern and southern hemisphere populations to confirm these surprising findings. So there you go. More research is needed.
Always. Isn't that always the case?
37 pairs of twins and 50 children.
Oh, that's such a small group of.
Yeah,
it's small.
Yep.
But the twins have whorls that all go in the same direction more often. Yeah.
Mm-hmm. Anyway,
all right.
Sorry,
the medicine prize. Moving on. Medicine prize, Switzerland, Germany, and Belgium for demonstrating that fake medicine, like a placebo, that causes painful side effects can be more effective than fake medicine that doesn't cause painful side effects. So if you're going to make a placebo, make sure it hurts.
Because then you're willing it to do something because you're in pain.
It's making me feel bad. It's obviously doing something.
That obviously means it's real also.
Yeah.
Wild.
Yes. And why does it have that painful side effect? That is the question that you should be really concerned about.
Seems like this was a follow-up study on a drug rollout that just had a bad side effect and didn't work. And they're like, how do we save this?
Exactly. In physics, James C. Lau in the United States for the study Neuromuscular Control of Trout Swimming in a Vortex Street. He demonstrated and explained, when it comes right down to it, the swimming abilities of a dead trout. Okay. The trout was not alive. Right. The second study that was named was passive propulsion. It's dead
So,
fish in vortex
hang on.
flakes.
Hang on. Before you rush to judge this dead fish swimming study, like,
This is
kind of
it's a-
brilliant. It's kind of brilliant. If you take out the motor function,
Is it mostly
of the
or only
how
partly
much
dead?
of the basic design of the trout allows it to accomplish its goal? Yeah,
Mhm.
like
Yep.
that's
How much
actually
is just
kind of
like the dynamics or the
Mhm.
structure, right?
yeah.
Mhm.
How much is that design contributing to its ability? Like, I think it's a kind of brilliant study, actually.
It gives you a baseline. Yeah, that's actually yeah.
Mhm.
How
Mhm.
else? But I think it needs to be a floppy fish and not a days
No,
old
no.
stiff
That's
fish.
taking
It has
too
to
much
be
motor
able
function.
to. It has
You
to be
got to
able
take
to.
motor function completely out. You got to take the motor function completely out. Just what is the base structure alone contributing to
Exactly,
the
but it
trout
can't be.
swimming ability?
Make a
But it
trout
can't be
decoy.
like it can't be days old and stiff because then it's not just naturally going into the water,
Oh,
but
I
like
see
it's
what you're
dead,
saying.
but
Yeah.
just the water's just hitting it,
Can't be petrified.
not pet. Yes,
You
But
can
maybe
just
that's
use
why they
like
used a dead
ballistic
fish and not a
gel to
decoy.
make a fake trout.
but then it's not a real trout. I mean,
Yeah.
this is going to be a whole engineering thing now. How to make a trout decoy in physiology?
Really, I think they probably started there and was like, actually,
Just go to the fish market.
all we really need is a dead trout, like kind of fresh, but not. Yeah, brilliant.
Kind of fresh? Is it fresh or is it mostly fresh? Is it dead? Is it
Mostly
mostly
fresh.
dead? Partly dead?
Mostly
I don't know. Partly fresh. Physiology. We have Japanese and United States of America researchers who have discovered dun 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 mammals can breathe out of their butts.
Mammals?
Their paper, mammals. Their paper published let's see, it was in 2021.
You're saying breathe out.
Mammalian enteral
Right.
ventilation ameliorates respiratory failure. Basically, if you insufflate if you ventilate a mammal through the anus, that it adds oxygen to the system that keeps the mammal from suffocating, from dying, from not having enough oxygen. You can add oxygen. You can boof oxygen. Well, mammals, quote unquote.
Well, I mean, we already know turtles can do that. So,
but mammals.
I mean, the
we
lower
don't breathe in
and the
bubbles
colon
underwater.
Is really what's the word I'm looking for? Like absorbent, like not absorbent. Like it's very it
has a large surface area.
Permeable.
Yeah, and
permeable.
Very permeable. Thank you. It's extremely permeable. So there you go. It's not that far off from something I would kind of assume to be true, but you're not going to be able to keep somebody alive by putting in oxygen.
Maybe it's, just enough extra to help. If there is diminished lung function, that maybe it just helps. I don't know. We're not talking about just mammals, quote unquote.
I'm just trying to picture the new snorkeling method.
I'm not. I am not. I'm really, really trying. This is one of those moments where I'm really glad I can't picture things with graphic detail in my mind.
It's rough.
Probability prize, Netherlands, Switzerland, Belgium, France, Germany, Hungary, Czech Republic, all these researchers, they showed that when you flip a coin, it tends to land on the same side it started on. I think we talked about this one last year. Yeah, that the quote-unquote fair coin flip is not necessarily actually fair.
Interesting.
More often, it is not totally random.
So you have to make a machine that flips it from vertical. That would be the fair
on
way
the side.
to do it.
Yeah.
No, because then it flips it the same every time, and so that would increase the odds of whatever your first result was.
I would like to see Mark Rober build this machine. Yeah.
Like part of the randomness of a coin flip isn't just the coin; it's how it's getting flipped.
Well, you make the machine.
That's exactly it.
It hits it from vertical, but it's force determined by somebody punching a lever. Because then you have the human element.
Okay. Oh, okay.
Yeah, there needs to be some kind of a human, like, chaotic element to it to make sure that the randomness is there.
Yeah.
In chemistry, researchers from the Netherlands and France used chromatography to separate the drunk worms from sober worms. They didn't have a breathalyzer machine, so here comes the title of their study: chromatographic separation of active polymer-like worm mixtures by contour, length, and activity. How active were those worms? How long were they? Were like curled up inwards on themselves like a little ball, not rocking back and forth, not looking like they didn't feel very good? Or were they active, having a good time?
The worms had a tummy ache?
Little tummy ache worm. Yeah. Oh, thank goodness for wormatography. 2 more prizes to go. Demography prize goes to Australia and the UK for their work discovering that it's not necessarily true that places that are known for having all the longest living individuals are, special in that that's where the genes are, or that's where the environment or the diet is, or whatever. No, they're just really not as good as record keeping as other places. So when were you born? Oh, yeah. We'll just put that down.
So there's also a culture thing. I covered this once in a
I think you did.
Totally separate thing, because it was one of the a study out of China that went to this region that is renowned for having very old people, and they were testing microbiome. And one of the things I noticed is, like, one of the people in their study age range was from 100 to 117. I was like, 117? That's got to be like the oldest person on the planet. But they don't really mention that. They're just like acted like it was casual. So I did a whole drill down onto it to figure out how do they have the oldest people on the planet and nobody's talking about it? And then it turned out exactly that. Really bad record keeping. Like, nobody had a birth certificate until after like 1950 something. So the best record, like, verifiable person, the oldest verifiable person from that region was no more than like 72 years old. And the Guinness Book of World Records had gone there because the oldest woman in the world at the time was like 116 or something, 110, whatever they were claiming. But had also had given birth to her son past the age of 60. If you did the math on how old her son was, who was like, so it was kind of like, well,
highly unlikely. But I mean, if you are going to live long and prosper,
two really fascinating facts. But that's also a culture that region also has a culture where age has gravitas, where there's a respect your elder thing within the community. So if asked at some point to self-declare age when getting an ID for the first time, we're like, I don't think they had IDs until sometime in that mid 80s even.
Yeah.
And you were asked to self-declare your age, a higher number. So yeah, that makes sense. Like,
and we have one last award to announce.
The last Ig Nobel.
Biology prize to I don't know how to say that name. Fordyce, Eli and William Peterson, for exploding a paper bag next to a cat that's standing on the back of a cow to find out how and when cows spew their milk.
Why was the cat part of it?
Probably because the cat would be spooked and has claws and might hurt. I don't know. I don't know. But this was published in 1941. The paper is called "Factors Involved in the Ejection of Milk." Popping paper bags and cats, and I don't know. I have no idea.
So, Kiki, I have to ask a question now that I feel like I should know the answer to. But why are these studies from like 80 years ago being awarded Ig Nobels now? How does this work?
Well, they are suggested, so people find the studies and nominate them for the award consideration, similar to the Nobel Prizes, where it is, these differently though they can be awarded posthumously, I believe. But the idea here is not so much to be awarding the scientist for something they did very recently, which is a new breakthrough, or a lifetime of achievement, or a
Right.
very
Or something that has like a
important
lasting
discovery.
impact on how we live as a
Yeah.
society now, right?
Yeah. But the Ig Nobels, I mean, I have to say, I think there were probably enough studies last year that they probably could have just picked all studies from within the last year. But, it's fun to bring back and unearth
Okay.
creativity and interesting lines of research and inquiry from, different decades, right? What were people
So,
studying? How were they
so I
studying it?
just
Why were they,
I
where
don't
did the
understand
study
why
go?
this is.
Right?
I don't
What
understand
happened
why
there?
this is even an Ig Nobel, because have either of you visited a dairy farm lately? Like this is
Not
this
lately,
is
but yeah, I grew up out in the country, Justin.
this is standard practice at most dairies nowadays.
Popping bags
Before
and
milking, you place the cat on the back of the cow, and then it's no longer a paper bag. They just play a
it's a
loud
balloon.
sound through speakers now because
Oh, right. Yeah. It's actually, that's way better. I was thinking they have
yeah,
popping balloons and being really bad for the environment, but
they
no.
just have
Yeah.
have the audio system that makes a
Oh
loud
my
sudden sound.
goodness.
Yeah, this is how we get our milk.
Yeah. Well, it's super fun because we have generations of people coming to the Ig Nobels, and someday I do hope to be able to make it to the ceremony in person. And if anybody out there wants to check out the ceremony, it is available on YouTube and also through the Ig Nobel website. And we will have links on our website, twist.org, so that you can follow along and join the fun and enjoy all of it in the way that they did last week when these were announced. All right, let's move on from these Ig Nobels. We're late getting going, but I mean, the Ig Nobels are so worth it. I mean, I'm feeling like, though, that was like a long timeline. We were digging into the past there. And I don't know where else we would do that. Justin, do you?
Oh, yes, I have an idea. Corals.
Oh,
Yeah,
wow.
this is kind of a one of those things that you don't know until some scientist figures it out and tells you about it. Sea surface temperature in the Fijian archipelago in southwestern Pacific is at its maximum, highest, warmest temperature for at least the last 650 years. This is the result of an international research team's evaluation of a coral record. Basically, what they've done is they made a 2-meter long core from a very old colony of coral.
I get it. Core. All.
A core of coral.
Exactly. Coral. Yep.
So these coral only kind of grow on their surface 3 to 6 millimeters per year. And it's basically a skeletal structure with a chemical composition that it's temperature dependent reactions of adding these layers. So they have this strontium calcium sea surface temperature reconstruction. Basically, what from what I'm getting from this is it's a uranium into thorium sort of thing. So uranium we think radioactive material, but there's micro amounts sort of everywhere in the soil and water. It's not harmful. It's just normal little micro bits of uranium. Uranium breaks down into thorium at a very predictable rate. Right? It has this half-life, but when it stops being uranium, then it becomes like parts of thorium, or becomes thorium. It's sort of this, but we know it has a like atomic clock sort of pace at which this takes place. So once these layers are getting infused, the calcium is brought in the surrounding waters, what have you. That process brings in little bits of uranium, and then that process can begin. So when you drill down through a core, each layer through that core is a different ratio of uranium and thorium in their micro amounts. And because of that, it's a clock for time. So you can go, aha, I know how old this is. I know how far back this is. I know what point in history I'm looking. And there are some corals that are out there that they know to be maybe 1,000 years old. But this one that they got was about 650 years old for their 2-meter core. And so they have this atomic clock that you can tell how far back things are. And the chemical composition of the layers can also sort of tell them what the ambient sea temperature was. So we have basically a atomic clock and a thermal record going back 650 years. Really amazing. We need to drill more cores into corals to get further back, find maybe even an older one to go back even further. But this is still pretty amazing because this is one of the oldest temperature readings that we now have. And it can go, this one is all the way back to actually 653 years, I think, before present. And the ratio of skeletal strontium over calcium with lower ratios being related to higher temperatures is showing us that right now, hottest it's been since 1370, which I guess if you been following the news about global warming and all these sorts of things, it's not probably a big surprise that we're at the warmest sea temperatures that we've been in 650 years. It's probably going back way further than that, but this is another data point in the sea of data points that are illustrating what's been going on.
It's just another one of these studies that just gets to the core of the issue about how our planet is warming. And yeah, it's just another piece of information, another piece of data in how we're, I don't know, it's what do we do, Blair? This next week is Climate Week. Next week, right? People are going to be in New York City. They're already in New York City. There's people talking all over the place this fall. Not Copenhagen, but the IPSS is probably going to be, or whatever, the COP people, they're going to be talking about what they're going to do about emissions.
Yeah. Just don't panic. Focus on large scale solutions. Vote.
That's a big step this fall.
Talk about it.
Yeah. I think that's a big one. Let's all talk about it, everybody. If people have questions, ask them why they have those questions. What are they worried about? What are they interested in? Let's talk to each other and see if we can get to the bottom of this person by person.
Worrying about climate change can be really isolating. So talking to other people about it and knowing you're not the only one concerned makes it feel less isolating and less scary. So knowing that you're part of a community makes things feel more achievable. I'm not saying we're going to get back to where we were, but we can certainly slow down the change and we can help our communities adapt to where we're going as well.
That's huge. Yeah. Be supportive. Be a giver, be a helper, right? Like Mr. Rogers. Be a helper and find the helpers, right? Thanks for the help, Coral, in giving us this little bit of information. Blair.
Yes.
We're going to move from coral, which are animals, but not animals. Kind of, they're interesting. They're animals. And we're going to move into sedentary animals.
Plants. Yes, people, especially when I worked at the aquarium, everyone thought corals were plants. Nope, they're animals. Anyway, but plants often care for, nurture, house, feed animals. And so they are pretty important to my interests. There were two really cool kind of just like headline stories from this week about plants that I wanted to share. One was that conservationists are finding ways to nurture and grow endangered species of plants in the Mariana Islands, and that is by putting mirrors underneath the little saplings. They know that colored
is that
plastic
happening?
mulch actually has been used for decades to reflect sunlight to improve crop production. And so they were like, hey, what if we just put mirrors down there? And so putting mirrors underneath these little baby plants, it allowed more than 70% of incoming ambient light at midday to be reflected back up. It increased the seedling survival rate by more than 160%, and growth in plant height increased by more than 170%. So obviously this is not something that you could do to an entire forest, but it is something that you could do to individual plants if you're dealing with an endangered species that needs nurturing, and it could help them grow big and strong. So pretty cool.
I don't know if I would do it with an endangered species. Like,
Well,
Why?
if you're trying to nurture the endangered species, why not?
yeah, but is it like I don't know. I don't know how plants work, but it seems like if you're getting something to grow faster than it normally would, you may be putting it into a strange configuration.
Okay, so hold
Like,
on.
this sounds more like
No.
house.
No.
Hold on.
Yeah.
Breaks. So with
Yeah.
plants, the seedling
question, though.
stage is the most vulnerable. And also that is when they are in the understory of a forest where there is the least amount of light. So this is when plants die. This is when you lose plants. So if you can get them to grow big and strong quickly, they get out of kind of like the danger zone, and they are more likely to survive for the rest of their plant life. So that's really what they're trying to do. They're trying to get them out of the like the trample and eat up all in one bite zone, and most importantly, out of the shadows where they can get their own light for photosynthesis.
Yeah, so it wouldn't be like forever with the mirrors underneath them. And you also want to be careful about the mirrors, make sure they're flat surface and not parabolic so that you're not accidentally like focusing
Bursting
light
them into
on-
flames. Yeah.
Yeah.
I know those are the first things I thought of.
Yeah, what do you
Well, Northern California, Central Valley kid. This is the first thing I thought about too. Is like this would just burn down any crop.
Right. So again,
This
No.
is
because
already
in a
like
forest-
almost too much sun.
right. So,
Northern
there's this
California
is,
ag.
these plants need more light. Their survivability is low because they are in the understory. And if the plant was not endangered, that would be fine. Like 50% of plants would make it, and that's okay. But if it's an endangered species, then you need to nurture those individuals and not lose them.
I can
And
see
why
like
are they
you're in a-
endangered? It's usually because insects and birds and other animals that are pollinators and seed dispersers, that they have also moved out of the area or gone extinct themselves. Maybe it is a climate related issue. Maybe it's because
Could be
humans have come in and destroyed
species.
everything. Could be disease.
There's a lot of times that
Yeah.
an invasive species of
Give them a
plant
leg
will
up.
accidentally will choke out native plants or will
English
create
ivy.
too much shade, as we were just talking about, and that will kill them off. So, yeah.
and then those invasive plants are usually harboring their own microbiota in the soil or soil biota. I don't know how you call it. That is actually transforming the soil beneath the plants so that
Many
they're
times they-
native.
Stealing
Yeah,
nutrients
they
from the soil.
change the
Yeah.
pH of the soil too.
Mhm.
Yeah. Make it more or less conducive. So many aspects there.
Yeah.
I love
And
this
then
This is
Well,
great
it's like-
advice if
it's
you've
like
got like
taking-
a
it's like
foggy
taking-
region that you're trying to grow something in. It's
Yeah.
like it would help also then I would think in like a lower light thing, like trying to grow a house plant in San Francisco or like in the Pacific Northwest, trying to grow a tree in your front yard, even though like the sun is not shining for like 200 and something days out of the year.
Yeah, the tree in the yard is one thing. I mean, I think people in San Francisco have for years had the indoor plant grow room situation figured out. So.
Right.
Well,
So
good
speaking
point,
of
good
stems,
point.
the other plant story that I have is that long stems on flowers are indeed an adaptation to encourage bat pollution in some case, pollination. To encourage bat pollination in some cases. So the long and short of this, is that the long stems make the bat flowers more visible, quote unquote, to bats in an echolocation context. Basically, what they did is they had backgrounds without any foliage and then backgrounds with a lot of foliage, and bats showed no difference in the time it took them to find flowers with long versus short stems in the simple backgrounds without foliage, but in complex backgrounds with arrays of leaves and flowers, bats took twice as much time to locate short-stemmed flowers as long-stemmed flowers. So those long stems stick them up out of the kind of the noise of other plants, so that when they're trying to echolocate and find the flowers, they go, oh, right over there. So it's very quick for them to find those flowers to pollinate. So yeah.
All for the bats.
Yeah. Good reminder that bats are pollinators. Lots of people forget that. And also that, oh, Kiki, you are muted.
I was just going to say that's what I was thinking, though. The reminder that bats are pollinators, because you usually just think of them going out and killing eating the insects, except for the ones that.
I mean, that does kill them.
but there are nectivorous bats, and those that are, so those nectar feeding ones they're feeding on flowers, and they need to see the flowers. And how do they find the flowers? Well, the flowers have to find them too. So the flowers are like, hi, I'm out here. It's like that person on the sidelines of the Tour de France with the cup of energy juice for the cyclist with the arm out. Like, here, take my juice water.
Perfect.
Nice.
Yeah.
I feel like we talked about this, but I also, or maybe I just read it. I don't know. There was some look at if we removed bats, like a significant amount of the bat population, how the corresponding insect population rises. And it like the cost of combating that rise in insect population and the detriment we would do to ourselves by trying to use poisons and all these other methods, like, and on top of that, they're a pollinator. Like, bats are our friends.
Mm-hmm. Indeed.
At least the ones that aren't harboring, like, totally deadly viruses. They're our friends.
Most of them are harboring. I know. I keep muting myself so that I can stretch my legs and bounce around over here and make noise and not bother people. But then I forget to turn it back on. And yes, but I was going to say most bats are harboring some amount of pathogenic disease. They have higher body temperatures, and they are reservoirs for a lot of things that would make us sick or make other animals sick. And it's just, that's it. They live in very dense populations usually, and there's a lot going on there. But they can be our friends too. Friends.
Don't even snuggle with them.
No, they're the ones that you just know. They're your friend. That maybe it's like they occasionally send you an Instagram text or something, or the TikTok or whatever, to let you know that they love you. And that's like you see them outside the window at dusk, and it's like, ooh, that was a bat. That's exciting. But the rest of the time, you don't see them. You don't know if they're thinking about you. Whatever. And they're there, though. They are always there. They're your friends.
Yep. I'm doing it.
Okay. I'm battering on here. So astronauts do not breathe out of their butts. We don't have space snorkels.
Great story, Kiki. No comment.
I was watching Blair take a sip of water, and I'm like, oh, timing. Okay, sorry. Anyway, like I said earlier, no filters tonight. I need to get more sleep. Researchers, though, are really, really concerned about how they can create sustainable oxygen recycling in space environments, or what they quote unquote call in their study sea of stars. That's where our future is, apparently, according
to always been. That's where our entire past has been too.
In the sea of stars. Anyhow, these researchers, though, were looking at current technologies that are in use aboard the space station and other craft that would and could be used for maintaining human life. And currently, we do not have a 100% accuracy or useful oxygen recycling technology. Currently, they have a state-of-the-art Sabatier technology, and it has a theoretical oxygen recovery of about 50%. So that's theoretical. That's not even practical use. And practical use is then going to be much less than that 50%. Okay, so now comes in their proposed method. It is using light and chemistry, photochemical combination. It's a methodology in which they would take the expired breath of astronauts, the carbon dioxide that is breathed out during the respiratory cycle, would then be put into a system in which there is a catalyst, and carbon dioxide would be split into carbon and oxygen through photochemistry. And in the process, make carbon nanotubes. So they would be growing carbon nanotubes, which would be a super strong structure over time that they could harvest and potentially use for, manufacturing and various uses, processes, etc. But the catalyst doesn't break down over time substantially. It doesn't get mucked up. The carbon nanotubes grow out like little hairs from the catalyst point, and potentially what they're using, they call a photochemical Bosch process, and it has a theoretical efficiency of 100%. And in their
well, wait a second.
In their theoretical, that's what I'm saying.
Everything has a theoretical 100% point.
They didn't test it. No. The Sabatier is only theoretically 50% oxygen recovery. This is theoretically 100%. And this wasn't on the space station. They did their work on, planet Earth in a laboratory, but their work had a over 60% recovery rate. And so that in itself is already better than what they're seeing on the space station with the state-of-the-art technology. So potentially this Bosch photochemical process could extract oxygen from carbon dioxide under fairly mild conditions and produce carbon nanotubes just from people breathing out a little bit of light and a thermoelectrocatalysis application. Harvest light. Use some chemistry. Make oxygen and carbon nanotubes. Just breathe.
But I want to say a thing.
Say a thing. Do it, yes.
Great. That sounds like...
it's all theoretical, Justin.
That sounds like carbon capture on a space station. It's a great idea. But hey, don't we have a need for that on the entire atmosphere right now?
Very good point.
Why wouldn't we just do that everywhere? Why would it have to be an in-space thing? Or maybe that's the source of the funding for this, and that's why they're looking at it that way. But which is fine. Like all sorts of things that are developed for the intense situation of putting humans in space can be applied elsewhere. But that sounds like just like a carbon capture and product output.
I think what they're talking about also, though, is the turnover. So how fast does the formation occur? Is it rapid? Is it more of a long-term recovery? And I think this might not be a fast reaction. But if it's
not fast, if it's not like you could set it up on carbon capture on the planet's surface to do this, I guess it's just, I don't know. I don't know why it would have to be on the space station. I guess you were going to, if you didn't have another system in place, you would eventually be getting too much carbon because they're having to do carbon capture of some form.
Mm-hmm.
Of course, on the space station.
The space station is more of a closed system. There's more money being invested in space than, just people living on the planet right now. No, I'm kidding. That is not true whatsoever. But I think it's a great point. And I do think that this is a technology / methodology that would not just be useful on a space station or a deep space human inhabited spacecraft, that this could be something that could be used here on our very own planet and put to great use. So I think you're right. More solutions, everyone, for here and in the sea of stars. All right, I have one more story for the first part of this show, but you have more. Do you have another one? Justin, what did you want to talk about? You had something else. What are you cleaning up?
This is actually this is from a story that I got from Paul Rogers, Bay Area News Group, and it's, I think, just kind of interesting. It's the September in California. Every September, thousands and thousands of Californians rush to their local beach, lake, or river and start picking up trash. One day out of the year, they just spontaneously all go pick up trash.
It's better than spontaneous combustion.
It's not spontaneous, I will tell you, as someone who has spent months planning 5 different sites for California Coastal Cleanup Day.
Oh, nice.
Actually, so
yeah, California Coastal Cleanup Day it's Saturday, right? This coming Saturday?
Yes.
Perfect. It's a statewide spring cleaning that takes place every fall. This year's Coastal Cleanup Day is, and correct me if I'm wrong, is between 9 a.m. and noon on Saturday, which is only 3 hours. They only ask you to come out to these things. Volunteers are still needed. I don't know if, hey, maybe one of the sites you go to will be Blair's. So if you are out that way in California, every county except for one is participating in this.
Except for one?
Well,
so when they say coastal, I mean, the San Joaquin,
every county except for
Central
one.
Valley.
I guess
So the idea
they've
is
got
that
rivers and
it's rivers,
any
lakes,
garbage,
creeks.
even if it's not physically in a waterway when you pick it up, could and probably will make its way to the ocean.
That's a great logic.
So you are diverting pollution from entering the waterways, even if you're not physically at a beach when you do it. So you can have a pretty big impact no matter what.
Do you know how, like, other states that do this or other countries, or like, how widespread is this kind of an effort?
Yeah. So I arrange 2 huge cleanup days a year in my day job. So there's this one, and then in May is National River Cleanup Day. And so that's usually the 3rd Saturday in May, and that is national. So that is the whole country comes out and picks up trash for that as well. I found out that recently the 3rd Saturday in September was deemed National Cleanup Day. So they've kind of ridden the coattails of California Coastal Cleanup Day and the
just
coastal
clean up. Maybe your room. No.
There should be events happening nationally, and I do believe there are some countries that join in as well. Some countries have their own cleanup days that are nationally recognized also.
Fun facts. You ready?
Yeah.
Since 1985, 1.7 million Californians have picked up more than 26 million pounds of litter. Top 10 commonly found items from 1988 to 2023, by however means they have collected this data over time. The most frequent trash found at the beach?
Cigarette butts.
That's it. Cigarette butts is 35% of their litter haul.
Yep.
Food wrappers and containers came in second at 10%, followed by caps and lids, followed by bags and paper and plastic, 7.25% of the trash picked up. Cups, plates, forks, knives, and spoons. Not the sort of thing you think about, but I guess people go picnicking and leave their trash behind. 5.34% of overall trash. In the 2 to 4%, straws, beverage bottles, glass, beverage bottles, plastic, beverage cans, all the way down at 2.41%. Now, cans have a recyclable like thing to them, right? They're worth a little bit of money, I guess, if you turn them in yourself. So that might be why they're
bottles. Yeah, they like the
glass and plastic do too. You're
Yeah.
right, but those
So
are all
a lot
down
of
in
the
the 2 and
testing has to
3%.
do with what is blown around by the wind also. So things that are heavy are less likely to get blown out of garbage trucks or dumpsters or trash cans. So that's why like plates are really big and bags and food wrappers, because they're very likely to be blown into various areas.
As bad as the
blown into bat caves.
Yeah.
as bad as the amount of trash being found is, not all of this news is bad. California beaches and waterways have gotten much cleaner over the 40 years that they've been doing. This is the 40th anniversary of this project.
Oh, it's younger than me.
So we've had a couple. First of all, we've had it says in 2004, volunteers picked up an average of 18 pounds of litter per person.
That's a lot.
Last year, 8.2. So either people are getting much lazier,
or more people are getting involved,
or more people are getting involved and finding less trash,
or people are getting better at not throwing things, just littering generally, which I'm going to
or maybe there are multiple pickup events now happening through the year, and people are being more conscientious. Yeah. Either way, they also point to some recent changes in California law. This was 5 years ago. California, under Newsom, banned smoking on state beaches and state parks. There's fines involved with it, at least. But that means that cigarette butts, which also I think smoking has been on the decline, has dropped down to 21% of the total litter from last year, which was down from that 35 to 40% high in years past. Plastic bags have been, that was the previous to Newsom, Governor Jerry Brown, 2014 signed a law banning plastic grocery bags. Now we have those totes and things you can get, right?
And if you are listening somewhere, I'm just going to add to this beyond just national, the international coastal cleanup is the website at theoceanconservancy.org. Hashtag see the change. They have a map where around the world, so globally, you can use their map to find someone coordinating a cleanup effort somewhere near you. So if you are anywhere in the world, this weekend is the weekend for cleaning up around the world.
Yeah. And these things are, you kind of got to fight for this. There was actually a challenge to that plastic bag ban. I don't know if you remember this, you guys, but there was a ballot measure that was put up to overturn the plastic bag ban. It was put up by the pro-litter lobbyists the plastic bag industry, who didn't want them to be banned. But they used to make up 8.7% of the trash found, and now it's 1.3 last year. In 2009, it was 8.7. Last year, it was 1.3% of the trash. So these policy things where you're getting rid of like some of these things that continually show up. My favorite part from this story by Paul Rogers, though, was at the end. It was in Yolo County, which is the home turf for certainly me and Kiki. Yolo County volunteers found a 5.25-inch floppy disk, and it grew a lot of astonishment as none of the young people who found it had any idea what it was.
They're like, the save icon for my computer. What is this?
No.
We found an artifact. We found an artifact from the past. This is the source of the iconic symbol we've all been using and had no idea what it was.
This was an arrow target for the people. The hole in the middle of the floppy disk. It
has a small switch that doesn't seem to turn anything on or off, but just makes a hole.
It's a very odd piece of paper for sending messages on. I mean, they used Sharpie markers. What?
Yeah.
This is great. Yeah, I am excited to see that beyond the California coastal cleanup, which is fantastic just for California because it has a lot of coastlines. This is global, and how neat, Blair. I hope your events are going to go great this weekend, and I hope that a lot of people get out there and clean things up so that we can keep the trash out of the oceans, so that things like the plastic ocean thingy, that went around was
gyre.
Yeah, but the project that got money to go and try and just take the surface off of the ocean and get the plastic just off the surface, they don't have to do that, because if we want that ecosystem at the surface, yeah, at that interchange between the sky and the water, if we want that to exist and thrive, let's get out of it. Let's stop getting the trash in it. Let's stop trying to mop it up with our ships. No, let's get out of it. So keep the trash out of it. Let's clean up our trash, everybody. Don't be lazy. Let's get out there. Just like cats. They're not lazy.
Really?
No, but I'm going to talk about cats later, actually, during the Animal Corner. That was just a tease. I'm going to talk about a new idea that the Earth might have had a ring at one time in its history. So we look at Jupiter and we think, or not Jupiter, Saturn, and we go, oh, Saturn, that's a cool planet. And the Cassini mission went there, and it was like, look at the rings. And Saturn actually has some little rings, and Uranus has like little rings as well. We used to think, oh, these rings, they're like the stable thing. Where did they come from? They must have just formed at one point, when the planet came to be a planet, and that's just the way it is. But Saturn's rings and Uranus's rings and all the rings that are in our system, they might go away. They probably will go away over time. And researchers looking at crater history on our very own planet Earth, they looked at the surface of our planet, pockmarked in this certain sedimentary layer with evidence of particular asteroid belt bombardment, a particular period of time called the Ordovician period in the Earth's history. It was about 40 million years or so of time in which our planet was bombarded. And strange thing, though, looking at their evidence, they're like, why are all the craters, if we go back in time and put like these spots where we're seeing the craters and the evidence of these meteors on the planet now, like if we put them all together in the old conformation of the continents on the planet, it was like it was around the planet at just about 30 degrees in the southern hemisphere, between about 20 to 30 degrees in the southern hemisphere. And it was like that ring around the planet. If it had been random bombardment from the asteroid belt, it should have been random, should have been much better than people flipping coins. But instead, what they had, the way that the researchers set up the significance of this, it's like as if you had a three-headed coin, or a three-sided coin, which you can't, and then you got tails 21 times in a row. Which the significance of like how these craters and the evidence are located on our planet is just like, why? This is weird. And so then they started hypothesizing about how it could have been possible. And one of the things they think is that maybe there was a big asteroid from the asteroid belt. It broke up at some point and got near our planet, and part of it crumbled, and it got trapped in our gravity well, and got all the little bits and pieces of that bit of asteroid shattered and ended up making a ring around our planet that was stable for a period of time and could have blocked light from the sun and led to a glaciation that would have impacted evolution of life on the planet, and it possibly did. And then when it became destabilized and started landing and dropping things on the planet, because of the way the ring was located and how it was oriented, all of its little pebbles and bits and pieces fell around the equator, which would have been just about where the evidence lines it all up now. It's an idea. It's a hypothesis. We don't know, but this is they're figuring out a story. It's a nice little tidy story, but it's fascinating.
It is. And I'm wondering, like, is this like separate from the big thing that hit the Earth super early on that formed the moon?
Yes.
Formed part of, like,
yeah.
okay.
Yeah.
But that debris, because that debris
yes.
from the moon should have already been resolved, or could that be the same?
This is when we had there was land and water. This is during a period of time when continents were formed. The Earth was, it's an old period, but it's a continental period.
And is it? How long ago was it? Maybe I missed you said the period, but I'm not familiar with the
Ordovician. And they Ordovician, yes. And the Ordovician time, they are known around the world as these Ordovician impact spike craters. And around the world, they seem to be randomly located. But then when you go back in time and put all these land masses back where they used to be, they're all neatly kind of lined up in a way that is more significant than chance.
Yeah, but that's also, isn't that how like all the rings work? Like, isn't that how gravity is working somehow on this spinning planet, that things tend to land towards near the equator? I thought that was a thing. Maybe I'm completely wrong about that.
No, but I mean, a lot of when things from space hit our planet, they usually hit somewhere out in the ocean in random places because there's a lot of ocean. But
there's a lot of ocean at the equator too, like a lot.
But when things buzz us and end up coming into our planet, they could hit anywhere. It all depends on where they're coming from in space, right? Yeah. So every other bombardment is more randomly located. Yeah.
I thought there was a tendency for it to be equatorial, but maybe that's an illusion, or has more to do with where we launch from the beginning, where things are put in orbit. I don't know how space works, but it seems like that's a pretty common thing. Like rings, like I think maybe even Pluto had like a faint ring to it. It's certainly got satellites.
Pluto has a faint atmosphere. I know that. I'm not sure. Yeah, maybe rings. I don't remember. Yeah,
but it seems like that whole like even like galaxy has a disk, and so you can sort of think of that as it's I don't know, hemisphere. Like all of these things like sort of like seem like it's just the way that gravity works on a spinning object going in. But that's fascinating. Like it could be an asteroid wreck that's helped cool the Earth and then was responsible for the beginning of life on this planet from some random interluders into our
but it's also like
does the moon have evidence of this? Because the moon hasn't gone through a whole bunch of tectonical shifty things. So how do you figure out
the moon has more evenly distributed, more randomly distributed impact craters?
So how would you? I'm just wondering how you would age them. But I'm taking tangents. I'll be right back.
Oh, everybody's going to be right back.
Oh, where'd the blood go? Okay, I'll hang up.
Yeah, no, it's okay. I think it's time to take a break, everybody. So with this, put myself back on the stage. Who's doing what? I don't know. I'm clicking buttons. Why am I still awake? I don't know. I'm doing TWIS. I hope you're still awake. Let's talk about science. Yes, craters. Within 30 degrees of the equator, despite more than 70% of the Earth's continental crust being outside the region. It's an anomaly that conventional theories cannot explain, according to the researchers. So, I don't know, a ring system around planet Earth. It's a fun idea. I'd love to see how it plays out in terms of what impacts a ring system, or a ring, maybe not many, would have had on light on Earth, and then also cooling and warming and glaciation and evolution of life. This is This Week in Science. Thank you so much for joining us. It's a long start to this show tonight because we're all so happy about the Ig Nobels and the fun of science. This is the show where we like to talk about science. And if you are enjoying the show, please head over to TWIS.org and click on the Patreon link, become a supporter. Support us at any level of your ability, from $1 to $1,000, whatever you're able to give, $10 and more a month, and we will thank you by name at the end of the show. There are also fun rewards that get sent to you as well at different levels of support. And if you're into TWIS merch or other fun, cool things that help support the show, head to our Zazzle store and do your buying. Let your wallet do the talking. Is that what it is? I don't know. We do, no matter what, appreciate your support. And the big one is, if you really enjoy us, don't keep us to yourself. Share us with a friend today. Get other people to subscribe to TWIS. Make sure they're here so they can talk with us about all the fun stuff that's going on in the world of science. We cannot do this without you. Thank you so much for your support. We are hopefully going to run through the last part of the show here. What do you think, Blair? Maybe, I don't know, maybe a half hour? Can we do it?
Oh, sure. Let's try.
Let's do it. I'm exhausted. But we are back. We're here. We've got more. And you know what the best part is right now? It's time for Blair's Animal Corner with Blair.
She loves our creatures, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
Well, let me start by telling you, if my internet will allow it, I don't know what's happening, about bumblebees. So this week in cognitive abilities only ever assumed in humans.
Oh dear, here it comes.
Bumblebees, they misremember things from time to time. When they are presented with when they're presented with a variety of stimuli, they can misremember, which is a key component of the episodic memory system, which psychologists argue is uniquely human. They were presented with colored yeah, I know. I feel like any animal with memory is going to misremember things, so y'all are crazy. But anyway. Bumblebees were presented with colored objects soaked in sucrose, like an orange strip of paper or a yellow rounded paper stick. Some time passed, the bees are presented with 4 objects. One they saw previously, one made up of 2 features of the objects presented previously. So maybe instead of an orange strip, it was a yellow strip, and then it was an orange stick, right? So like they mixed up the variables basically. And then one with only one feature of the objects, maybe a purple stick, right? And then one that was completely new, like a candy cane. And I made all these up. I don't know what they do.
but really, it could have been this.
Yeah, absolutely. So then they were tasked with selecting an object by exploring it with their antenna or their proboscis. And among randomized trials, they remembered to go to the original object to seek out the sucrose a lot of the time, but also occasionally made mistakes. They would select a similar stimulus of a different shape or color. So they didn't go for the whole new thing. They didn't go for the candy cane, but they did sometimes make mistakes where it was like, oh, I remembered part of this, but not all of this. And so this is
because they're mixing up some of the details with, so like it's this color stick, but that's the same color, but a different material or a different shape. Like,
Yes. So this is what's called memory conjunction errors.
hmm,
And they're a usual form of memory distortion. And this is something that is seen in relation to a particular type of memory that many psychologists think is uniquely human, and that's the episodic memory. So this,
even though we know that birds have episodic memory, episodic-like memory.
I know. Yeah.
Yeah.
So I take issue with all that, except to say that I think it's very interesting that in this case, messing up a memory actually proves complex thought. So basically, the way that they messed up, the way that they misremembered is a key through research that they have cognitive processes that were thought to be too complex for them. And I think that is very cool, that like the way they mess up indicates a higher bit of intelligence than previously was assigned to them.
And also, this isn't so
Right.
much about bees being forgetful. It sounds like bees can be tricked.
Right, just
Yeah.
they're like, I remember something about it's like if I was like, oh, I met this person. Their name started with a T. Was it Tiffany? Was it Terrence? Was it?
But you remember they had brown hair
Tyrone?
and you
What?
met them at the cafe or,
Right.
you at the dog park or whatever,
Yes.
right? Yeah.
Yes. Oh, and I
You remember
remember that
other details.
dog, or like, like whatever. You remember specific elements. And so you might go and call them Tyrone, but their actual name is Tyler, right? And so
But then the next time you meet them, they say their name is Bob. Like there's also like, isn't there like a little? It
so
feels like
that,
there's a little
but
bit
that's the
tricky.
thing. That's not a recombination error. That is not episodic memory. That's you just messing up.
Mhm. But there's a
Unless
certain
you know
amount
a
of
Bob
yeah.
who looks like him. And then
Yes.
you're like,
And that's what I
oh,
feel like they did was that they switched. They had somebody reintroduce themselves with a different name, and you're like, well, I remember your name, but you're telling me it's something else. Like that's not fair.
yeah. Well,
Yeah. So
yeah,
there's
so
like
I
there are
mean,
different psychological tricks that are done in these memory trials, right? To try and get to the nut of what is actually being remembered.
absolutely. Yeah. So you have to kind of mess with these variables to say, like, okay, what about this makes you think that this is where the sugar is? And so the fact that they were picking specific elements of these items that were related to the original item, and that the majority of the time they still picked the correct item, means that there was memory going on, but that it wasn't just like, it wasn't a specific flash image that they were responding to, which I think is what the original expectation was, that it was that because their brain is just like a ball of nerves, that they weren't able to do this complex categorization and memory processing that we do to sort through the sheer volume of information that we take in every day. We have to sort through the memories. And so I think that's the other piece, is that people often misidentify animals' cognitive process as simplistic. But think about how complicated what a bee does is, how they have to remember where they're going, how they have to communicate with each other where they're going and where the good nectar is and all this kind of stuff, right? So like there's a lot of complex communication and memory and cognitive process going on in a bee.
And I think one thing to remember here also, not just the bee aspect, but like, survival, right? This is a test experimental setup. So these bees are not going to starve. They're not in the like early winter, like getting ready to hibernate, and the researchers have taken all the food away kind of a situation. This is not happening. The bees have, they can find food. They're doing great. Everything's happy. So in lots of experiments with many animals, including humans, when the stakes are not high, errors are higher. And so I think that might also be something to consider in this as well, because there's a certain amount of, okay, well, if I'm not going to die from not making the right choice, then if I don't make the right choice, there could be a benefit to the exploration as well.
Yes.
Knowing that I remember one part of it, it could be, Yeah.
I
So
might
there's
find a new
something
thing,
else.
new
There's
source.
something else that I'm just thinking of right now too, which is that plants that are related often look similar.
Like
And
plastic
so
ones and their neighbors.
is there actually an evolutionary advantage to recognizing categories of things and go like, oh, the last time I ate from, or like, oh, I'm trying to remember that flower I went to, it was
Oh,
conical and orange. Oh, this is a conical flower. I'm gonna eat from this conical flower. Is there an evolutionary advantage to using
yep.
category labels to remember plants because of relatedness?
Yeah.
And of course, that prospecting is how like they will be able to be transported from one end of the country to another and pollinate different things, because they're not going to not check everything out at some point. They're going to look into every plant to see what's
Or
possible.
at
What
least
do you
the
got?
categories of plants that they know are usually fruitful.
Exactly. Yeah. So
Yeah.
categorization, pretty important.
Gonna call in Tyrone. Sorry, you got that in my head now.
So from misremembering things to misidentifying or just not even noticing things, us
Yeah,
humans
all the time.
may have a hard time recognizing when there is a beached dolphin.
Excuse me, what?
Yes, let me explain. So
Ooh.
in this study in Alabama, researchers put decoy dead dolphins out on beaches.
Okay.
Why did they do this? To find out
I'm
how often they get reported. So the decoys were tagged with a phone number to call when a member of the public happened upon them. And so the idea was this data would give rates at which stranded dolphins are found and reported, and identify areas where fewer decoys were detected, like remote marsh areas, that may merit extra scrutiny by trained observers. So
This
this
is
is
already
important.
reminding me of the crow studies, where they would put out fake dead crows, or maybe real dead crows, and then see how other crows interacted with them. Only this experiment is on humans. Yeah.
Yeah. So that's, and we'll get into that in a second. The whole like, did people not notice them, or did they not want to approach the dead dolphin with a phone number on it? But anyway, there's some help for that kind of potential variable coming in a minute. But the way that people report them and how often they are reported is important, because the stranding networks use the public as their primary source of information for stranded animals, but also because it's important to know what the reporting numbers are for stranded dolphins for conservation. Are the number of strandings of marine mammals in general way under what is actually happening in the wild? That impacts conservation kind of plans, right? So the public in general only found about 50%, 58% of the decoy dolphins overall. So that is not great. For every 100 found, there may be close to twice that many that strand that don't get reported, right? So this is called cryptic mortality. So there needs to be more information for dedicated searches on that. But then they also did some trained observers. They deployed them out to try to find the decoys. So they found out the public's about 58% effective, right? But the trained observers searched over 2-hour windows, and the staff members who normally don't have as much time to just be out there all the time, but they can go to specific areas that they know are going to be like harder to detect beached animals at. They used kayaks, they used ATVs, they used drones, and the train staff found 3/4 of the decoys in the off season and 83% of them in peak season. So they did better, but still not great. And then they used a drone. Like, let's see if we can find them by drone, because we're already walking ATVs and kayaks like maybe we just can't get to where these drones have been placed. Are we just missing them? And some decoys were found by drone. Similarly, some were found by walking that weren't seen by drone. So it was like not super effective. So the mix of techniques is important. But ultimately, there were some that were never found. Some decoys had to be pulled eventually by the people who placed them there because no one ever found them.
Okay. I thought it was the researchers who couldn't find them. Except it was like,
The researchers knew where they
found
were. Then
found
they
a
trained
decoy dolphin,
people
decided to
and
take it
sent
home.
them out to find them.
Okay.
To see if the
So
rate was better
this sounds like
trained observers.
potentially traumatizing to people who saw it from afar. Was like, oh yeah, we're not going to the beach. Oh gosh, there's dead dolphins in the beach. Can't even go to take the kids to the beach anymore.
It wasn't like littered with
Crazy.
dolphins. It's not a lot.
So you know what this reminds me of? I don't know if you remember Kiki Rancho Seco, or Blair. Maybe you know what Rancho Seco is also. Rancho Seco is a nuclear power plant that they were going to build in Central California.
Nuclear, yep.
And one of the things that they did for a protest, which was sort of like an ad hoc research project, which environmentally not as sound as the standard today, maybe, is that protesters released thousands of balloons with a phone number. And it said,
found
if
one.
you found this,
I did find
call
one.
this number, Rancho Seco or something. Anyway, so they released thousands and thousands of these balloons during this protest. And the calls came in from several states away, having found these balloons in like backyards or wherever they find, wherever these balloons came down again. And it was being used to illustrate if there was a problem with Rancho Seco, you too are part of this argument about whether or not the state of California should allow this plant to be built. And actually, it was like, I think at that point, already built pretty much. And this is like, I don't want to get into the whole nuclear power is safer than this power or better for global warming, because I kind of agree with that, but it's not really the point. But it is an interesting thing when you throw that sort of data out into the physical world and get that human population to observe and be part of your study. It's actually pretty amazing sometimes how frequent or infrequent, how much these things are missed, how you could have a bunch of dead dolphins on a beach and nobody notice or just nobody investigate it. There's also a possibility. Saw it from afar and was like, ooh, we'll go down. Who knows?
Not everybody is curious.
Not everyone is curious. Not everybody.
And sometimes because of tides and because of various factors, you might notice something, but you can't get out to an area because it's treacherous or whatever. There's lots of factors involved.
But now these missing decoys.
Not going to make excuses for people.
None of them are missing. They knew where they all were.
The researchers knew.
The researchers
knew. The point was to see if people could happen across them.
Now, if they had given people $50 when they found a decoy, then people would have been out there like, oh my gosh.
Maybe. But I think that's the problem. You don't get $50 when you find a real dead dolphin. So you have to kind of match the likelihood, because that's the point of this study, right? Like, are we generally underreporting, and by how much?
And dead is one thing. A carcass is one thing versus a still living, just stranded dolphin. So if you catch one that's still alive, that's the point.
Yeah.
Right?
And I think that's the other piece of this that's kind of hard to measure. It's the human element of how many people saw it and didn't do anything.
Mm-hmm.
And how many people see dead dolphins and don't do anything also. Is it the same amount? If it's the same rate, then that's great. You're testing the same thing. But if it's a different rate, especially if it's like, oh, I have to do homework now, I have to call this phone number. I wonder how many people saw it and they were like, nah,
everybody has a phone with them these days.
Yeah.
And
but
I imagine the coastline of Alabama.
No way.
I don't know. I would be curious. I'd be like, what happens when I call this number?
Sure.
What is that?
I mean, you or I definitely would, because we'd be like, oh man, this is from a research lab. Cool.
Such a nerd.
But somebody else, maybe not. And, like I said, if you see a struggling beach marine mammal, I think a lot of people rush to report them.
Mhm.
But if you see a dead animal on the beach, I think most people don't do anything about it.
No.
So
Yeah.
the fact that they're not being reported doesn't mean people aren't happening across them also. So that's kind of the other piece. But
Yeah.
ultimately, I think what was learned from this is that, yes, we are underreporting marine mammal beachings, but that also sending out trained staff to do surveys of a space is really important because it increased the accuracy quite a bit. Like 30% is a pretty big uptick in accuracy. So
I wonder how much though you could get local groups. So say, like this weekend is the cleanup weekend, right? So you have people going out there for that. Maybe these people are also interested in coastal areas. Maybe they're outdoors and they're in these places a lot. How many everyday people, right, can be trained easily? See something, say something, right? If you notice something on the beaches, here's the phone number. Like, I don't have a phone number for that. I wouldn't know the first thing about what to do, right? It's like I could probably be there and like try and look something up on the internet, and figure it out eventually. But I mean, I think there's a public information aspect, a communication aspect that's missing here as well.
Absolutely. Yes. And Zombie Tom Hanks is asking in the chat, what it makes me laugh every time. What do people do with deceased beach dolphins? It depends. But in a lot of cases, research or rescue organizations will come pick up the animal to test them to see why they were beached. It's really important to know, were they carrying a pathogen?
Especially if they're a
have brain
mammal.
damage? In some cases, did they suffocate? Why did that happen? Did they drown? A lot of beached marine mammals drown. And so you have to ask why. Sometimes you can figure out it's from like blunt trauma from being hit by a boat, and then they knock out and they drown and then they beach. So it's really important to know that because, for example, I know the Marine Mammal Center in California has identified pathogens that are moving through the marine mammal community off of the coast of California by checking beached animals. And you can actually kind of check that, start to treat that, catch it early, and help save species that way. So in most cases, those animals found on the beach will get recovered and tested to see what happened.
And I'm just going to let you know that from the Institute for Marine Mammal Studies, I know Fada has been putting some things in the chat room here, but there is one phone number that you can call if you find a dolphin, which it says here typically strand because of injury or illness and generally will die without expert assistance. You can call the Institute for Marine Mammal Studies Stranding Response Team at 1-888-SOS Dolphin. Dead or alive.
That's great.
And this is anywhere on the Mississippi Gulf Coast.
And a
So I
quick
would
note,
say, as a rule of thumb, if you see an animal in distress ever, you can generally call your non-emergency police number, and they will route you to animal control or other nearby organizations that would be appropriate, depending where you are and what the situation is.
and one of the number one reasons they've been finding, at least off the coast of California, in the sea lion population out there, that pathogen that is getting into the marine mammals, Toxoplasma gondii. So be sure, never
could be all sorts of things. Bacteria, algae, there's all sorts of reasons.
But there's a toxoplasma crisis in marine mammals right now off the coast of California. UC Davis has got a whole bunch of research out on this, and they're finding alarming numbers and the behavioral changes that are taking place that are causing starvation and weird. Anyway, never flush your cat. Never buy a flushable cat litter. Never flush your cat litter. Don't. People do this, but never, ever do it. This is what's killing marine mammals.
Apparently, also, there is a dolphin and whale 911 app that you can download if you spend a lot of time on the beaches. stranded marine mammals can be reported if you have an Apple device. Keep your distance from a sea turtle, stranded marine mammal, at least 50 yards, and don't get near the tail flukes.
And I'll just throw out there also, it is a federal offense in the United States to approach, touch, mess with, disturb marine mammals. It's called the Marine Mammal Protection Act. Don't do it.
Yeah.
Don't take a selfie with a seal. Don't approach. Call instead.
Wait, so
You
it's a
see life?
felony to have approached the dolphins? That's amazing. Well, it's amazing they got as high.
If you look at those
response rate as
photos,
they
it's
did. It
pretty obvious.
was
It looks like
Alabama.
a dolphin-shaped trash bag filled with sand. So
They do. All right. Well, speaking of dolphin-shaped trash bags filled with
yeah.
sand, let's
Uh-huh.
talk about cats very, very briefly. Justin, you mentioned the cat litter aspect, but what about how come cats don't get stuck in little tiny spaces more often? Well, some
There's
researchers,
some-
I always thought it was
included.
whiskers. Or is it whiskers?
they do
It's
have
how
the
long their
whiskers.
whiskers are.
That's
This
part
is
of
what-
it.
I don't know how this might not be true at all, but this is what I heard.
Part of it. It's part of it.
How long their whiskers are. They go in and they feel like, oh, it's touching the edges of the thing. That
And they have
means it's
whiskers down their
too
whole body.
narrow.
Yeah.
Yeah. Have what?
Vibrissae. They have these tactile whiskers that are different from the rest of their fur, mixed throughout along their bodies, so that they
Oh, I didn't
not
know
just
that.
their faces, but as they go into spaces, those generate signals that can help out. But anyway, this study that was just published in iScience, it's an open access study. If you want to take a look at it, researchers put little openings in sheets of cardboard and made them smaller and smaller and smaller to see when the cats started deciding not to go into the openings and what they did and why they did it. And so they measured the cats, and this study, which I love, is cats are almost liquid. They selectively rely on their body size awareness as they're deciding whether or not to enter any kind of opening. So in this study, they looked at the length, the width, and the girth of the cats. They created, if you've seen like YouTube videos, there's some
I've seen these
people
on
out
TikTok.
there.
Yeah.
Yeah, you'd use a sheet of cardboard and you can make progressively thinner or taller or shorter openings for cats to go through. And they found with these differences that the cats had a number of different strategies. Of course, different cats and different body types had different ways of interacting with the world. But one of the things I thought was most interesting is that up to about the third thinnest and also third shortest opening, the cats were just like, whatever, go right through. The majority of them are just like, do, no hesitation, everything's great. The fourth and fifth trials, things started getting a little skinnier or a little shorter. And that's when the cats started hesitating a little bit more or looking for different options. So the cats, the researchers said, started trying to figure out different ways around or over. Specifically, the taller the cat was, the more likely they were to try to jump over the barrier as opposed to going through it. But I don't know whether, it's a function of just the opening sizes that they used in the cardboard, but it seems like the cats were like, whatever, okay, I'm getting used to this. First time, okay, cardboard, whatever, I'll go through it. Second time, okay, it's a little thinner, but fine, I can still do it. Third time, they're like, okay, I'm familiar with this. I know I can fit, whatever, I'm just going through, no hesitation. But then it gets to a point where it's like, and it's interesting that it's for both the fourth and fifth, the skinniest and the shortest, that lead to the most hesitation. So what is it? And it's a dramatic jump from pretty much very little hesitation and just rushing right through the opening to suddenly going, wait a minute, I gotta kind of look at this a little bit more. But the researchers found not all the cats act the same. And they like looking at all sorts of different options as well for making their way through. But Yeah, pretty much cats are like, yeah, I know my body. I got my whiskers. My whiskers tell me what I need to know. I'm a long, lanky, flexible cat. I'm gonna make it through. It's all good. I'll get through here. Cats, they're almost liquid. Justin, do you want to tell a story?
Yes, and I'll try to be fast because I know we're a little bit over the time this week.
Well, we started a little late, but we are a little over the time as well. Let's get through this.
Concrete is one of the most fascinating subjects that seems to come up quite a bit on the show. This is a basic material that everyone sort of assumes has been perfected, seeing as how it's very, very old and it is holding up so many buildings and it's on all of the sidewalks.
But it's also bad for the environment.
But yeah, it hasn't been perfected. So, right, it's an active field of study for several reasons. One, it could be better. Roman concrete has lasted thousands of years for some structures, while modern concrete has got a lifespan of about 100 to 150 years. Two, the manufacturing process, it's a huge part of the greenhouse gas emissions. Three, it just could be made stronger. It could be made better. It would reduce, if we can make it better, we reduce the maintenance and the replacement frequency saving infrastructure costs, as well as reducing greenhouse gas emissions, building design possibilities. We'd have every architect with a zany vision license to go out and create new spaces. But it also has, the third one is that it also is very brittle.
Right.
So yeah, kind of a big deal.
If
you
it
can
cracks,
make concrete,
is it going to shatter? How's it going to? Yeah. Not all concrete repairs itself.
Nope. And so you can't make concrete without cement, because cement is the binding agent for whatever else you're mixing into your concrete. The main problem, though, is that the cement is brittle. You might not think of concrete as a brittle thing because it's certainly hard and sturdy. It's not fragile, but brittleness has to do with how a thing breaks, how it fails. So if you have a wood structure or a steel structure that's at its capacity but aging or deteriorating in some way, it will begin to deform. It will bend or sag or maybe start to splinter a little bit. But when concrete fails, it tends to do so by cracking. And then if that's taking place, when it does fail, it's a sudden failure. It's not a gradual thing. Concrete, there can be gradual cracking and this sort of thing over stresses, but when a concrete structure goes down, think of a building collapses in an earthquake or a dilapidated bridge. When it goes down, boom, it goes down in an abrupt, catastrophic failure. And that catastrophic failure is a failure of cement. Okay. Engineers at Princeton have developed a cement-based material that they say is 5.6 times more damage resistant than its standard counterparts, which is huge improvement. Team was inspired by human cortical bone, the dense outer shell of human femurs that provides strength and can resist fractures. Cortical bone consists of these tubular components known as osteons embedded weakly within the sort of organic matrix of the bone material, calcium depositing material. Unique architecture actually deflects cracks around these tubes. It prevents abrupt failure and increases overall resistance to crack propagation. So in this new article in the journal Advanced Materials, the team demonstrates that cement paste deployed with a tube-like architecture can significantly increase the resistance to crack propagation and improve the ability to deform. So creating a material that can deform without the sudden failure, without just cracking and breaking. And brittle construction materials used in building and civil infrastructure, strength ensures the ability to sustain loads, while toughness, which is what they're working on, supports the resistance to damage over time. So this could be much longer lasting because of this. When you have it longer lasting, that means less replacement.
Mhm.
Less replacement means less need for new concrete
Which
to be
is
made
better
out of the cement.
already, right? Yeah.
Yeah, and so then that's one way that it would be reducing greenhouse gases. This isn't necessarily a greener method of making the cement, but it would be a greener method by creating longevity of the material.
So let me get this straight. We're not actually using human bones to make concrete.
We are.
Is using
We are.
the
No.
architectural,
It
the
is human
structural
bones that we have
integrity,
used as the model.
the model. Yes. We are not
What?
grinding up bones and putting them in cement for
That's
sustainability.
actually a
This
great
is
idea.
architecturally.
Well, they haven't looked at that yet. They haven't looked at that yet, but
I just want to clarify, Justin.
yeah,
You're
but they
selling
are
it.
actually their next step is to infill some of
Grind
these
their
tubes.
bones to make their bread. That's the next step.
It is very much like bread in this weird
Oh, dear.
because cement is basically the flour of concrete, the bread. Does that make sense? That's sort of the analogy,
Mm-hmm.
right?
But
It's a main
if you
ingredient.
structure the bread appropriately, you get sometimes your bread falls and you get a flat, icky, dense bread. Other times it's lofty and airy and it's perfect and hard, crusty exterior.
But the next step is they're taking different types of soft materials and seeing if infilling the tubes with these materials can actually give them an even better deformation ability and therefore longevity with the toughness. It's very cool.
Tough Freet. It's like it's a brand name, isn't it?
Concrete, still making headlines in science after all
Yeah.
these years. It's amazing.
Not really with human bones. Where did he go? He had one more story, didn't he? He disappeared. I think he turned himself off.
Mm-hmm. I guess
In the meantime, let me dive into my stories for the end of the show. I know Justin has one more, but we're chatting about all this stuff. I love talking about science communication and misinformation and disinformation. Blair, do you think AI is better or worse for the spread of misinformation and disinformation / conspiracy theories?
it is better at spreading disinformation.
And that's what a lot of people have come to believe because the algorithms that form the basis of a lot of these generative AI models, not really all artificial intelligence, but who knows how intelligent they really are. No, they're not intelligent. They are generatively predictive and probabilistic. But anyway, some researchers just published their work in Science on ChatGPT. And they're finding that ChatGPT or a model that's similar to it was really, really great at helping people to dispel conspiracy theories and myths. They found that because the algorithm is based on this large data set with a lot of information, where a debate or a conversation may have someone who is falling prey to a myth or a conspiracy theory, more likely to say, well, what about this? What about this? What about this? And name off all the things that they've heard. And you have to have an encyclopedic memory and be just like, this is what you do all the time to really be able to address all of the possible detractions or possible, other framings. ChatGPT or a model that's trained to specifically talk about climate change or evolution or whatever it has to be, all they have is it's a depth of data and a depth of evidence. And so whereas a human might get tired and stumble or not have all the information that would be useful in these conversations, a ChatGPT like algorithm can continue to discuss and doesn't invoke emotion and doesn't get upset, just speaks to just the facts. And they found in their study that the algorithm was able to repair some of the misconceptions that a certain percentage of their sample set came into the study with. There's, like we've talked about historically, there's always the people at the extremes who are never going to listen, but they argue that we should be using algorithms to help fight disinformation.
So what I find very interesting about this is that
it can go both ways, though. Yeah.
Well, yeah. Like, I mean, I'm sure you could ask or use or give prompts to get it to come up with a conspiracy, right? But yeah, I totally agree with this because it's all about sources. If the brain in the human you are speaking to is sourcing their information from Twitter or whatever it's called, then yeah, they're going to be sourcing you bad information, and they might have a lot of it because they may have spent a lot of time doing their own research by other people whose brains are sourced from this sort of misinformation. If the AI is sourced, its knowledge base is research studies and is not allowed to be trained in a sense or sourced from the Twitter sphere. I guess I can say Twitter because now you can't get sued for making fun of Twitter or blaming Twitter for things because it doesn't exist. But we all know what I mean. Does that kind of work? Anyway, I'm not a lawyer. Anyway, that I think is the
ask ChatGPT, Justin. If that's,
I think that's why it could work so well. I think I totally agree with that because it's where people are getting their information that's causing all of this. Dogs and cats getting pets getting eaten, whatever nonsense that has been being thrown around.
But I think that's the same hesitancy that I have about ChatGPT in particular, and also I forget whatever Google's AI currently is.
I think it's probably Google AI, wouldn't it? Like they name everything Google something.
I think it has some. They all have some sort of fancy
Gemini.
name.
Yeah,
Gemini.
It's only Apple that's kind of messed up because they'd have to be AI. You can't say that.
But the sourcing is exactly the thing that I'm nervous about, and that's the thing where you see all the whoopsies in the AI preview on Google is all based on pulling from a source that is not correct. And so I think that's exactly your point, Justin, and that's the piece that I think so many AI creators kind of, I'm going to just say, kind of rushed to launch these items, these systems without figuring out how to
ensure
that check the source material, right? Make sure that they're using credible resources, or that you only feed certain information streams into the AI, right? And so I think
that's going to be it's going to be the big into the future, right? How do we ensure that the large language models for these generative algorithms, that they are trustworthy, so that then the algorithm and the platform is trusted and trustworthy as well? And how do we ensure that right now it's still kind of a gimmick, and you can do a test situation and people come into it and go, sure, I'll listen to this, whatever. And there is a propensity for people to want to trust the technology more than another person that they don't necessarily know. And there is a certain amount of, it's just the scientific information, and there's no human bias attached to it, supposedly. And so, I mean, how many times have you tried to have a debate or a conversation with somebody who just will not hear what you have to say, and you have to shut the conversation down, or you're going to get upset?
At least once a week.
Right? And so an AI is not going to do that. A language model, a generative algorithm is not going to go there unless you told it to, right? Unless it's been instructed to be a cranky scientist.
So part of it, again, I want to go back. It's sourcing. Because Blair, what you're talking about with
Sourcing is
some of
essential.
the AIs that had like what is this AI, like the AI that got like real racist and misogynistic right away. Part of it is coming from attempting to reach the level of the Turing test. Is it the Turing test? Is that the one where you can't tell that the computer is a computer? It sounds like a human. Because a lot of these early language models were trying to do, can we be the customer service center automated bot? Like, let's create that first, because that we can sell. And so what they had available to them is troves and troves of trillions of online conversations that they could use to train the AI on. That's what the source was. So they were basically using Twitter and other chat rooms for their data source to try to teach it to sound like a human.
Don't
And
use social media as your
like,
data source. That in
that's
itself is going to be just not okay.
right, but that's what
The
that's
worst
the
of
data source
humanity.
that they have, right? That's the data
Yeah.
source that they have. Like they don't
It's
have,
open. Yeah.
they should have just used this show. My goodness, we've done this
I
for
think
20
so.
years, a couple hours a week. Like
Yeah.
there's
I need a
plenty of
computer
data here.
I need somebody who writes these generative models to help me write one for TWIS. And we've got
Yeah,
a lot
we
of
just like kick back. It's like, oh, look at this. This is a better disclaimer than I ever wrote. I'll just do this.
yeah.
So
But yeah,
again, but
I
I
think
think
that we
that
can't
sourcing,
just
it doesn't
focus.
seem
Yeah.
like ChatGPT spent its youth trolling chat rooms to learn about the humans. It seems like it got a lot more from actually like literature and scientific papers. It seems like it was given a good, healthy upbringing as opposed to some of the others.
Yeah. So far, ChatGPT is not Skynet.
No.
I started watching the Terminator anime. And
Why?
it's great.
Sorry. What?
Yeah.
What?
There's a
Why?
animated Terminator series. It's very good. It's been released finally. I'm very excited about it. But yeah, no Skynet, no ChatGPT. Come on, people. Let's be thoughtful about what we're doing. And speaking of thinking and being thoughtful, researchers published in Trends in Cognitive Science question, or at least a study considering learning by thinking in natural and artificial minds. So learning is the addition of new elements to your understanding, to your noetic awareness and understanding of the world. And you can learn by observing. You can learn just, by, I saw a thing, I respond to a thing, blah, blah, blah. It's integrated. But you can also talk with somebody about things. How many people had, those teachers who said, had the questions for thought aspects, so you're just sitting and you have to think about stuff. We talk about thought experiments. We talk about reasoning and rational, like trying to not subjectively, but come to understanding objectively. Can humans only do that, or will algorithmic intelligences do this as well? Can you have algorithms think about something? Is the output the product of thought, or is it just something that looks like the product of thought? And anyway, question for thought. So, I thought it was a good philosophical and interesting question, way to compare natural intelligence and artificial intelligence and learn more about both moving forward.
I think if bees are thinking about stuff, AI is not going to be far behind.
Do it.
Like, I don't mean to put the bee down. They had, a billion years of evolution like all the rest of us to get where we are today. But I feel like there's a little bit more resource with the AI.
I don't know. Bees have big old colonies. Blair, what were you thinking?
I think, a true AI would learn, right? Isn't that the whole idea, and why people are constantly telling us in chat, it's not really AI? So we use it colloquially as AI. I'm not going to be able to stop doing that. That's just how the whole world now talks about this. It's how it's been labeled. The definition's changing. But if you want to talk about what true artificial intelligence is, I think that would be the piece, right? Is that it would be able to learn and adapt on its own. But what we have currently created doesn't seem like that's part of it. So the
Which is
question
a good thing,
like,
maybe.
right. So the question is like, can it
Yeah.
grow, and can we tweak it to become a true artificial intelligence that can learn, or is that not currently on the table? And I think that, I saw this AI expert talk about it, and they said, no, it is not on the table for this version of AI that we have. We are going to have to scrap it and essentially start over if we are trying to get to true artificial intelligence, which again, probably a good thing. I don't think we're ready.
So here's a couple of scenarios. In the future, you're going to have a government-based AI. This is the one that your state has sponsored and says, this is the answers you can get from your state's AI. You're going to have a corporate AI. This is this company's AI, and it's going to spin things maybe a little bit here and there. You're going to have a research AI that's like, I'm going to try to avoid politics in the corporate world because I don't want to make anybody mad and lose all my grants, but we're going to try to stick to the science and avoid these things. And what if they just don't agree? And then administrations can go in and change the algorithm for the government AI, and the corporation can get taken over by another corporation where
Again, this is
very rich person has an ideology that they want infused into the AI because they own the technology.
anybody,
It
like you
becomes
said, we've got
very,
multiple.
very much like the world we're already living in today.
Ooh, yes, but it is the AIs or the algorithms that are created by the corporations that get regulated by the government, but then become generally intelligent, and then they start talking to each other and training each other, and then they make their own algorithm government. Yeah.
And the only way we'll be able to have any secrets is with squid spy gadgets.
Ooh, tell me about that. Yes, please.
This is a flexible screen inspired in part by how a squid can store and display encrypted, can display images on its surface. And
I thought you were going to say squids could do encrypted messages. I mean, it is kind of.
Well, yeah, that's what they're
yeah.
So instead of having an electronic device, they have a magnetic field device that they're sort of creating for these screens. This is in the Advanced Materials by University of Michigan engineers, according to Jorg Lehan, professor of chemical engineering, co-corresponding author of the study. It's one of the first times, okay. So quick interruption. I get that a lot of research papers and press releases use for the first time messaging. For the first time, this is the first time that, please stop. For one thing, if this really is the first time, nobody cares. We want you to repeat it a few times. Let this be like the fifth time.
Yeah, novelty is great, but is it really something that's going to work? Yeah.
Yeah. Don't give me the first time. I want the 50th time. Tell me it's working. Okay. If it's not the first time something has been done, why bother working first time into the conversation? Right? Or 50th time. Anyway, quoting. It's one of the first times where mechanical materials use magnetic fields for system-level encryption, information processing, and computing. And unlike some earlier mechanical computers, this device can wrap around your wrist. Yes, ladies and gentlemen, you can get this squid-powered encryption device on your wrist. The researcher's screen could be used wherever light and power sources are cumbersome or undesirable, including clothing, stickers, ID badges, barcodes, ebook readers, and a bracelet. A single screen can reveal an image for everyone to see when placed near a standard magnet, or it can display a privately encrypted message when placed over a complex array of magnets that act like an encryption key to reveal a specific image. This is quoting here Don Pena Franesh, Assistant Professor of Materials Science and Engineering, and another co-corresponding author. This device can be programmed to show us specific information only when the right keys are provided, and there is no code or electronics to be hacked. This could also be used for color-changing surfaces, for example, camouflaged robots. So when I first saw this, I was like, future ignoble.
That's great.
Like
Let's
we
give
have a
robots squid
screen
skin.
that can encrypt information. And
Yeah.
like everybody has a cell phone. I think we said that earlier. Kiki said that earlier today. Everybody has a cell phone. Right? This is what would be the point of this? Well, in the future, where AI can see everything, understand everything, is everywhere, maybe this is how we will have to communicate the secret underground human resistance. Only then they throw in the fact that it can be used for robot camouflage, and we're all dead anyway. But yeah, exposing the
Didn't see that
pixels to a
robot on the
magnet.
street corner? Yeah, they were wearing squid skin.
Exposing the pixels to a
Blending in.
magnet will program them to show either white or orange in either a pulling or pushing magnetic field, state referred to as their polarization. For some pixels made with iron oxide magnetic particles, the polarization can be changed with relatively weak magnetic fields. But the polarization of pixels that also include neodymium particles is harder to change. Therefore, a stronger magnetic pulse is required. So this is the way you can sort of get multiple images nesting within this screened material.
So there can be encryption in the squid skin. Nobody
But it sounds like
here
it's
but
only
us
going to be.
squids, robots, and spies.
It sounds like it's going to
Robot
only be an
spies.
orangish colored material. So
Well, that's for
not
now.
really great camouflage if you think about it.
Orange is great. Orangey brown. Orange, you glad you're a squid? No.
Yeah, I still don't understand the usefulness of this, but that's the amazing thing about whenever there's a discovery that seems like it might be not have a great immediate use. We may find out this is the cornerstone of a future technology. Who knows? Have we done it?
I think it's fantastic. I love anything that is using natural systems for inspiration, for new technologies, for future uses. You start somewhere, and it will be used by people, or it will, form the basis of another thread of creativity and innovation.
I think we're going to see this on the runway.
Oh, that'd be cool.
Yeah.
Oh, that's so much sleeker than like the LED dress, like that. This is gonna get my Arduino and my squid skin tuxedo.
Yep.
Oh yeah, this would be good.
And the models will be walking down a magnetic field generator to switch up the outfit while they walk. It seems that actually might be fun.
Going to be very fun. Well, if you feel like you're getting old because it's getting late right now, and you feel like, oh man, these people, they keep talking about science, talking about all these things. Well, researchers have been looking at our brains and trying to figure out what is the difference between the young brain and the old brain, and how our memories are working or not working, or what changes. Anyway, these researchers did memory tests on people. And Blair, you were talking about the bees and their memories earlier, and how they make some errors. Well, as you get older, you make more memory errors as well. And part of that system that goes wrong is the deleting of old information is not as good as it used to be. So old information sticks around and clutters up your working memory. And so you tend to make more of those, like, where'd I put my keys? Kind of, memory errors. Little tiny things don't work quite as well. And the researchers in this study that was just published on beta band neural variability revealing age-related dissociations in human working memory. Anyway, lots of words, maintenance and deletion mechanisms. What they saw is that the older you are, the more likely that you have a change to what's called this beta band neural variability. You have less of it, or you have more beta band variability associated with making correct answers the older you get. So your variability increases and so this this responsiveness is changing. So there are brain changes that occur.
But it
And
sounds
these
like it's
could
being
be-
those changes also make you stuck in your ways a little bit.
yeah.
Although I have to say, I did overcome that problem with my older brain today. Because I think it's maybe the first time that I didn't refer to corals as a plant.
Because we already said they were an animal before you got started. Like we mentioned it right before you got started.
But I think I forget every time. Like I think that's one of those things actually. Because I think it's locked in there that it's some sort of undersea plant life. Because I can't seem to get rid of it. And I also keep calling, I don't even know what the real thing is, but I keep calling them meek rats. Because that's also the name of that little prairie rodent. Is it meek rat?
Meerkat?
Yeah, meerkat.
That's the one. But when you ask me any day of the week, and it's a meek rat.
Meek rat.
Because that's just, it's stuck. Anyway, sorry.
Yeah, no, our brains do have a propensity to remember the information that should have been corrected because your brain doubles down on that was the thing that was wrong. And so then you start second guessing yourself. And was it this one or that one or this one, that way? And more often than not, you're going to choose the one that is wrong and stick with the thing that was wrong. And it's just indicative of the difficulty in changing the connections that we have in our brain for a number of various reasons.
So it gets preference because
it gets harder.
It has more existing connections in your brain already.
Yeah, and then because you're like, oh, I should have corrected this, and you think about it, and instead of just thinking about the new correct thing, you think about the elephant in the room, or as it put. And because you spend more like processing power, there's more neural connections and strength feeding that network of the wrong than the actual right, even though you should have corrected it. And that's why we continue to make the same mistakes over and over and over again, and it's hard to break them. Our habits of remembering the incorrect. And it gets harder the older we get because of changes in the way that our brains neural networks are able to delete information that we don't need to be paying attention to anymore. Oh, I already remembered that phone number or that name. I don't need to think about it again for the next 3 hours, but I'm going to think about it over and over again. And I'm not going to remember anybody else's names or phone numbers because now my brain has been taken up with this other stuff. So, yay. You know what we can do to help our brains and to make sure that we don't have these problems with information sticking around, with the trash not being taken out? Yes. Sleep. That's what we all need, is a good night's sleep. To sleep, to dream, to clean out the cluttered brains. Yeah. To squeeze the cats. Y'all ready? Have we done it?
I think we did it.
Great. I did it. You did it. We did it. Yay! Thank you, everyone, for joining us for another episode of This Week in Science. So glad that you joined us this week and have been hanging out and chit-chatting all about the science that we've been discussing this week. Love it. I absolutely love getting to talk with everybody. One thing that I like to do before the end of the show is thank you. Thank you so much. Different groups of people. Chat room. Thank you for being here and chatting. To our Patreon sponsors, the ones that are in the Discord right now, thank you for being over on Discord. Fada, thank you so much for your help on social media and with show notes. And Identity 4, thank you for recording the show. Gord, Arenlore, anyone else who's out there who helps keep the chat rooms good places to be, thank you so much for that. And Rachel, thank you for editing the show. Also, of course, our Patreon sponsors for their support of the show. Thank you too. Let's see if I can actually get to that part of the thing where I share my screen. And we're gonna say the names. Yeah. Okay. Thank you to Eden Mundell, Alan Viola, Aaron Nathma, Arthur Kappa, Craig Potts, Mary Gertz, Teresa Smith, Richard Batch, Bob Colts, Kent Northcote, George Chorus, Pierre Velazarb, John Ratnaswamy, Chris Wozniak, Jagard Shefstad, Donovan Styles, aka Don Stylo, Ali Coffin, Reagan, Shubru, Sarah Forfar, Don Mundis, PIG, Stephen Alberon, Daryl Carl Myshak, Andrew Swanson, Fredos 104, Sky Luke, Paul Ronovich, Kevin Bearden, Noodles, Jack, Brian Carrington, David E. Youngblood, Sean Clarence Lamb, John McKee, Greg Riley, Mark Essenblow, Steve Leesman, AKAZ, McCann Hayes, Howard Tan, Christopher Rabin, Richard Brendamish, Johnny Gridley, Remy Dave, Britton Lattimore, Flying Out, Christopher Dreyer, Artyom, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Philip Shane, Kurt Larson, Craig Landon, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, Lon, Meg CEO, Adam Mishkan, Kevin Perrigan, Aaron Luther, Bob Caldery, Marjorie, Baldy, Disney, David Simmerly, Patrick Pecoraro, and Tony Steele. Thank you for your support on Patreon. Can't do it without you. If anyone else wants to be a part of this list or just to help us out through Patreon, head over to twist.org and click on the Patreon link. On next week's show,
we will be back Wednesday, 8 p.m. Pacific time, and again, 5 a.m. Thursday,
Same
Central European time. Broadcasting live from our Twitch and our YouTube and our Facebook channels.
Want to listen to us as a podcast? Just search for This Week in Science wherever podcasts are found. If you enjoyed the show, get your friends to subscribe as well.
For more information on anything you've heard here today, links and notes will be available on our website, www.twist.org, so you can go in and read the actual studies about which we speak.
That's right. And we love your feedback. If there's a topic you would like us to cover or address, or a suggestion for an interview, please let us know on one of our social media accounts, or better yet, just send us an email. Just be sure to put TWIS, TWIS, in the subject line, or your email will be spam filtered into a phantom ring around the planet.
What's our email? We don't give out the email.
Ooh, nah, they will guess it. Just figure it out.
It's on twist.org. You can find it.
You'll find it. Go get it.
Well, we look forward to discussing science with you again next week. And if you've learned anything from the show, remember,
it's all in your head, I hope.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.